Hi guys, so if you are doing a finite element analysis of a beam, a column, a slab, or any structure using the openseespy library, I think you need to understand this basic concept, which will help you to understand how the library works and its command. So you need to understand the element types that it uses. So it uses the 2D element and also the 3D elements. So in the 2D element, let's say we have a triangular element. So we have the nodes like this. They are connected at the node. So you have at each node you have 3 degrees of freedom. 2 are translational at the y and x axis. Then 1 is rotation, which is at the z axis. And for each of the nodes, that is how it is at each node. So for the 3D element, let's say we have a cube like this. So we have the nodes connected at this point. Then we have the nodes. So this one here, each node has 6 degrees of freedom, and 3 of them are translational. And 3 also are rotational. So that is the first thing you need to understand. So the next thing you need to understand is that when you are providing your support condition or your loading, it is either you provide the support condition at the nodes, or your load also will be at the node. Also for this one, it will be at the node. Then the next thing you need to understand is that so the command in the openseespy library is something like this, in which you have like 3 parameters when you are building the model. So the first one is the number of dimension of the model. So are you using a 2D element, or are you going for the 3D element? And then the NDF is the number of degree of freedom, which you have to specify. So you know that for the 2D element, we have 3 degree of freedom. And then for the 3D element, we have the 6 degrees of freedom. So the next thing you need to do is you have the next command will be like ops.node. So here you define your node. And the first thing you do is you have something you call the node tag. The node tag followed by then the coordinates of where the nodes will be. So like in this, you have the coordinate of this node, in which you have the x, the y, and the z coordinate. Also for this one and also for this one. So, but we know that this doesn't have the z coordinate, so it's going to be 0. So you have x, y, and z. But for this one, we are going to have all the coordinates. So z, x, and let's see, this is y. So this is z, this is x, and then this is y. The next thing is the boundary condition, which you can define it as using the command ops.fix. So like this, you provide the node tag, as the first parameter. Then you can, maybe if you want to define it as a fixed support, you provide everything to be 1, 1, 1, like this. So providing this 1, 1, 1, this is just like degree of freedom at each of the degree of freedom. So when you have 1, this is showing you that for that degree of freedom is fixed. And let's say when you have 0, it shows you that for that degree of freedom, it is free to rotate or to move. But this one is fixed and this one is free. So I think with this, you can go a long way to implement a lot of the finite element analysis. And the next video we are going to do is to go into the code, because I want everybody to understand it a bit by bit process, so that we can build a knowledge on this thing. And if you want to contribute, I'm happy to give everybody the opportunity to contribute to the platform also. So thank you. See you next time. And don't forget to subscribe.